In this video, we're going to be going over key points in Chapter 12, Inference for Linear Regression. The population regression line has the equation mu sub y equals alpha plus beta x. The three parameters for the population regression line are alpha, the true y-intercept, beta, the true slope, and sigma, the true standard deviation of residuals. The sample regression line has the following equation y hat equals a plus bx. The sample data can then be used to help estimate the parameters. B can estimate beta, A can estimate alpha, and S can estimate sigma.
Now let's go over the conditions for regression inference. They follow the acronym LINER. First, linear. Check that the actual relationship between x and y is linear. You should make sure there are no patterns in the residual plot. Second, independent. Check that individual observations are independent of each other. So, knowing the y for one subject doesn't help us predict the y for another. When sampling without replacement, check the 10% condition as well. Third, normal distribution. The y values should vary according to a normal distribution. The histogram of residuals should show us no strong skewness or outliers. Fourth, equal standard deviation. The standard deviation of y should be roughly the same across all values of x. Check this by making sure the residual plot shows roughly equal scatter for all x values. Lastly, random. The data should come from either an SRS or a randomized experiment. To determine whether a specified value of the slope beta is plausible, we can also perform a significance test, following the state plan do conclude setup. First of all, we must specify the hypotheses. Generally, the null hypothesis is beta equals 0, meaning that there is no linear relationship between x and y. The alternate hypothesis is beta is not equal 0, or beta is less than or greater than 0. Remember to define beta in context. Next, state the name of the procedure, t-test for slope. Be sure to check the LINER preconditions as well. For the do step, you need to find the test statistic t, equal to the sample slope b minus the null beta, divided by the standard error of the slope. To find the p-value, use a t-distribution with n-2 degrees of freedom. These values will typically be provided in Minitab output format. For the concluding step, check if the p-value is less than the significance level, typically 0.05. If it isn't, you fail to reject, and if it is, then you can successfully reject the null hypothesis, as there is convincing evidence of a linear relationship.
When constructing a confidence interval for the true slope of a regression line, we start by saying that we want to estimate beta, where beta is the slope of the population regression line at the % confidence that's given to us in the problem. We then move on to check the LINER conditions. Assuming those are all met, we can then use the equation b plus or minus t star times se sub b with n-2 degrees of freedom. In this case, se sub b is the standard error of the slope, given that we repeated the experiment or random assignment a large number of times. This can be interpreted by saying that the slope of the sample regression line will typically vary by about x from the slope of the true population regression line. In our conclusion, we say that we are x% confident that our interval from a to b captures the true slope of the population regression line. This can also be carried out on your calculator by going to Stats, Tests, and choosing the one that says Linear Regression T-interval and plugging in the values.
The values of the equation will typically be provided for you. However, if given a list of the data, you also use technology to solve for p by going to Stat, Test, linreg T-interval, or linreg T-test.
In order to achieve linearity, transform exponential equations by logging y, so your final equation looks like log y equals x plus b. Transform logarithmic equations by logging x, so your final equation looks like y equals log x plus b. And transform power equations by logging both y and x, so that your final equation looks like log y equals log x plus b.
When constructing a confidence interval for the true slope of a regression line, something to be cautious about is that when interpreting parameters, we need to remember that the values of the mean y-intercept and change and not for the sample values. And a common mistake is using n-1 degrees of freedom when in fact we use n-2.
On the AP exam, remember to define any variables you use, such as x, y, or beta, in context and with correct units of measurement. On the do step, make sure to include critical values for significance tests, p-value, and either the name of the equation or the actual equation written out in order to achieve full points.
Answer number 5 on the 2005 AP exam FRQ on slope inference for more practice.